Hello everyone. I've been wondering for a long time how these AC servos here can actually be run without needing massive industrial electronics. And it turns out it's actually pretty simple, and you can do it from an Arduino if you want. So, this is an AC servo, not to be confused with the RC servos that are these tiny little 5-volt motors that are in a gearbox and you can run with any Arduino. These need to be run with a servo controller. This is a servo controller. As you can see, it's this big box of electronics and it's got a lot of wires coming out of it. So these two adapters right there, or connectors, are for the servo. We have the servo encoder and the servo power supply, and the other gray bit there is the actual live voltage coming into the controller. This right here is the servo encoder, and that right there is a servo brake, by the way. I misspoke. This servo here doesn't have a brake, so it's just bridged there. And this is the 44-pin connector. And that 44-pin connector has a few wires coming down to this breadboard, which is also connected to this Arduino. And also to power the, I guess, control board of the servo, you're going to need a 24-volt power supply. This one here I got from Alpha Distributes, and you can see right there it says 24. And on this particular servo, it's connected negative to pin 37 and positive to pin 36. And live and neutral, naturally, this runs on 220 volts AC. Now, this servo here has DI1, which is pin 3, connected to the ground, which is V negative, as it's on and off. So right now the servo is enabled, which means that I cannot move this. And if I turn this off, I am able to move it without problems. However, you should not stop the servo in speed, or start it in speed, because that's very bad for it. Let's go ahead and run a bit of code. I have a bit of code here, which basically just sets up a few pins, and then we are checking for pin 6 if it is on high, and if it is, we're going to send a 1 kilohertz tone, and if not, we're going to send a 1 kilohertz tone. So let's go ahead and connect, disconnect, because right now we are at we're draining pin 6. So let's go ahead and set it to high. As you can see now, the servo is running, and I 3D printed this little arrow right there. And if we go ahead and connect it to this back, we will not move it. The way that this servo in particular is set up is that it's set up in step/direction mode, which is a very accurate way of holding your servo. But we can set it up in speed mode if you want, just raw power, but at that point you might just use a brushless DC motor. Yeah, let's go ahead and make this spin a little bit faster, I suppose. Or, you know, we can make it actually spin slower as well. So we can do this right here. This tone is the frequency generator, which basically just is exactly what it sounds like. Typing with one hand is always a little bit awkward. And here we go. Now let's go ahead and remove that comment and send this over. So we should be spinning now forward slowly, and then forward a little bit faster, then stop for a moment, Then we'll swap directions, spin a little bit back, and then we'll keep the loop going. So right now we're spinning fast, slowly, going back a little bit, going forward again, and as the cycle will continue. So that's all I've got time for this example, but it is definitely possible to run an AC servo off an Arduino. So thanks a lot for watching, and good luck with your AC servo projects.